Okay guys, so take out your Z-score notes, take out your table, take out your Casio, and if you have a laptop or a computer, go to Google and wait for me there. So let's do one more example and we're done with Z-scores, and then we'll do something else tomorrow, okay? So here we are, example, consider the following list. Consider the following list of lap times, okay? And they'll be in seconds. Consider the following list of lap times. Now, suppose that we wanted 9 pieces of information. So let's open up 9 commas, 8 commas. So 1, 2, 3, 4, 5, 6, 7, 8. And I have these written down somewhere. Here they are. So we have 27.96, 27.57, 27.43, 27.85, 27.94, 27.22. A lot of 27s. Where are these 27s coming from? So how many do I have so far? 1, 2, 3, 4, 5, 6. I need 3 more pieces of data. So do these numbers look familiar? Do you see where I'm getting these numbers from? Is there something that Lee tends to do or on some sort of a console that spits out times like these? Yes? So you see, we're going to go to Mario Kart, okay? Now, I'm not going to go to my classroom, although I could. But what I'm going to do instead is I'm going to do Mario Kart, and then I'm going to fill in those 3 times. So what happened is I brought the Mario Kart here, and it's on the ceiling. I'll show you in just a moment. I put the Mario Kart, I installed it on the ceiling. So I'm going to do one circuit with 3 times. And those 3 lap times give us a full set, okay? So I want you guys to look up here. Now, by the way, you're going to see me racing, but there are going to be 2 ghosts. One of the ghosts is the programmer's record. So the people who made Mario Kart 30 years ago, they had one of their technicians sit down and they programmed his ghost. He's kind of slow, so we'll bear with him. And then the other ghost is me, myself. So I'm sort of racing against myself and the technician who created Mario Kart about 1,000 years ago. So let's take a time out. Let's go to Mario Kart and we'll be right back. All right, close finish, but I defeated myself, okay? So what were the last 3 times? The last 3 times were 27.39 and then 27.78. And then that 3rd lap was kind of choppy. I missed one of the turns. I missed the power skid. Please forgive me. 27.91. Now, we have all of these numbers. It is only natural that we now go off and find mu and sigma. So 2 to the nearest, let's say 100th, to the nearest 100th, find mu and sigma. You might be like, hey, Lee, no way, bro. There's no way I'm going to take all these crazy decimals and find mu and sigma by using this crazy formula. Now, could we use this formula? Yes, we know how. But you know what? I think now is the time to reward you guys because you have been finding this the long way. This is the 5-minute way. But is there a faster way of finding sigma for a bunch of numbers like this? There is. So say bye-bye to this for now, okay? We know how this works. So instead, what I want you to do is to go to Google, okay? And I'm going to show you how there's a website that can give you mu and sigma for all of these numbers, and it can give it to you like this. Okay, so go to Google and in the search bar, type in standard deviation calculator. So you see, for me, it's already a popular search result. So I'm going to go there. Standard deviation calculator. It's probably the first thing that pops up. Go for it. It should look something like this. Yes, it should have this layout. So wipe off the numbers that are there and then type in all of your numbers and separate them by commas. So 27.96, 27.57, 27.43, 27.85, 27.94, 27.22, and then the new times 27.39, 27.78, and 27.91. So 1, 2, 3, 4, 5, 6, 7, 8, 9. They're all there. Now, don't hit calculate yet. You see how it says population and sample? You want to use sample. So if you take stats next year, your teacher will explain to you the difference. But for us, for now, always use sample, okay? So now calculate, and notice that, boom, right away. You see, it tells you right there, it tells you the standard deviation, okay? So just round it to the nearest 100th, which is what it said on the board. So our standard deviation is 0.28 seconds. And then where is our average? Our average is right there. Our mean is 27.67. So that's mu and sigma, just like that. So now let's take these numbers and go back to the main board. Okay, so we're back here. So you saw how technology can give us mu and sigma. How come I didn't show you this at the very beginning? Well, I want to torture you guys a little bit. But now at least you can appreciate how technology and computers can find these things for us in a jiffy. So what were they? Based on that computer, mu was about 27.67 seconds. And then what was our sigma? Our sigma was about 0.28 seconds. So I'm pretty consistent, right? If I can give myself props here, if I can gas myself, I'm pretty consistent because look, my sigma is really small, which means that my lap times are really close to each other, right? So it's pretty consistent. And you get really good at something if you do it for about 25 years. Okay, so that's it for this here. So there was just part A, there was no part B for today. It's all good. So now go to your exit ticket, try it. The answers are at the bottom. Let me know if you need help. Tomorrow, Wednesday, we'll do a different concept, and that'll be exit ticket number 3.